Good morning, this is Larry Martin. What you're looking at is my freshly converted Harbor Freight 12 by 33 lathe. It now has a 2.5 horsepower motor. It's out of a Treadmill. It has variable speed. It also has a reverse. It seems to work very well. If you have any questions about how I did this after you view the video, please don't hesitate to ask. I will respond to everyone as concisely and quickly as I can. So sit back and enjoy this, and thank you very much. Well, I mentioned in a previous video that I was getting ready to convert my Harbor Freight Lathe to a DC motor, variable speed. And I also told you that I would try to do a very detailed video on it. So maybe with some of my help, maybe some of you guys might want to do the same thing. So let's start off at the very basics of what you will need. I guess the first thing you will have to have is a treadmill motor. You don't have to have a treadmill motor, but I found through all my research that this is probably the most economical way to go. I paid $40 for this motor on eBay. I think it was like $14 or $15 shipping. So I had $54 in this motor. It's a variable speed permanent magnet. It runs up to 7,000 RPM. I doubt I'll ever need that, but that's what it runs. Okay, the second thing you're going to have is a control box. Now, a lot of people use the controls out of the treadmill itself. Now, there's nothing wrong with that. I just wanted something that looked a little more professional rather than, buttons that you bump it up and down how fast you want to run or slide. I wanted something more professional. So I have a K&B electronic drive here for driving a DC motor. Here it is. This is a case off. Here's the case right here, and you can see. Okay, I have wired it for 220 and it's plugged up. I also wired in a reversing switch. You can buy a reversing switch from K&B. They want $55 for it. Or you can buy you a switch off of, I think I got mine from Surplus City. Maybe I got it from McMaster's. I'm really not sure. But anyway, here it is. And that's what it looks like inside. It's very simple to wire up. I've already got this one wired. I'm going to do a little quick demo. You have to have it in one direction or the other. I'm going to put this one into forward. Okay, you turn it on. See the light come on? And you turn the switch up. Now to reverse it, it's hard. This is a safety switch. You have to pull it out, in, out, and down. So to reverse it, that's the way you do that. And you have to have the dial down and turn it back up, and it goes the other direction. And that's that. And that turns it off. Now, next thing that I have is I built a little box, and it's going to hold my tachometer, and I'm going to put a temperature gauge in it so I know the temperature of that motor. I've heard that they overheat. Getting back to that, I put a fan on the end of this one because I didn't want to use the big weight on the front. This is a computer fan. It's a 12-volt computer fan. That's a dog food can. It's put on there. And that's going to be a 12-volt motor that I'm going to run from a separate power source. Okay, pulleys. There's my pulley. It's a 5/8 bore. I had to hone it out a little bit to make it fit because this is metric. I also put you can see right here, I had to dimple or drill a little hole in the shaft itself for the set screw to hold. And I took and sawed off the end of the counterweight to make me a reverse nut, and it is on with red Loctite. Okay, the other end pulley is right here. Both of these come from Surplus City, as does the belt. I found that's the easiest place to get them. I believe this was $12. I think the little pulley on the motor was $6, and the belt was like $4. So that's that. All right. Now I want to tell you how to wire the reverse switch. I hope you can understand this. I'm going to do my best. Okay, here's what one of them looks like. It has 6 poles on the bottom. Now this switch is a double pole, double throw, center off switch, which means it has a pole here and a pole here all the way down. And it throws from the switch throws it's on one way, center off, and on the other way for reversing. All right. Now the way you wire this is pretty simple. You come into your control box. If you're doing 220, which I did, with line 1, line 2, and a ground. Okay, you have your 2 DCs coming out, plus and minus. You bring both of them to one end of the switch. You would bring them to here and here. Okay. You come off to 2 center poles to the motor. Okay, from there you build your 2 little short jumpers. And I labeled these, and you want to basically X the 2 ends. So you would come from A to C and from B to D to X those. And what that does is that reverses the polarity from one side to the other. And that's basically how you do it. One last little look here. Next step is I'm going to go in there and unbolt my lathe from the floor and bring it in here where I've got all the facilities and stuff, and start taking it apart. I'm probably not going to detail taking it apart unless I see something that I think I need to go back to and explain how I did it. But from looking at it now, I think it's pretty straightforward. I have a primary objective is that I want everything to be able to put the lathe back like it was. So I'm not going to be modifying anything on the lathe itself. I'm going to be building to it. In other words, I'm not going to drill a bunch of holes in it and stuff like that. Because if this does not work, or for some other reason I want to sell it in its original condition, I'll have all the parts to put it back like it was. So I will see you when I get the lathe in here and apart. Thank you very much. Okay, I got it all apart. Really didn't have any problem with the exception of getting the main inside part of the Reese drive pulley off. And that primarily was because it was just stuck. And it's made of some sort of pot metal. And I did break a little bit of it. I think I can fix it. I was trying to use a rubber hammer as a friendly persuader, and I just hit it a little too hard. I've got it over here now. The little JB weld on that one little piece right here. JB weld is wonderful stuff. I doubt I'll ever need this thing again. And if I really do, I maybe just end up having to buy another one. It can't be too expensive. But that was the only problem I had. I have another problem, a little slight one. I assumed, and you know how that goes, assume will make an ass of you and me, I think is what they say. I assumed that this shaft was 1 inch, because that's 1 inch. But it's not. It's smaller, it's probably metric. So the pulley I bought has a 1 inch bore. Now, it is keyed. I can buy another pulley and bore it out. They don't have metrics, but what I think I'm going to do is not really that much here. I have some stainless steel leading edge tape for airplanes. I think I'm going to put a couple wraps on that shaft right there and see if I can't get it tight and snug it down. And if that causes a problem, it wobbles too much, I'll just have to order another pulley and give it a few more days. Hate to order one right now because I'm not real sure that's the size I want. I may have to go a little bit bigger. Can't go much bigger, the housing won't allow much. Right now my ratio is going to be 2 to 1. So if the motor's turning 1,000, my revolutions will be 500 supposedly. It's just a little less than 2 to 1. So my next step is try to get this pulley on. All right, I've got the pulley on with a stainless steel tape. Got the key in it. It's really nice and tight. There's no slack in it. I'm going to try it that way. And I'll check it often. If it looks like it's going to be a problem, I'll order a pulley with a little smaller bore and put it over there on the metal lathe and with a boring bar and clean it out a little bit. I checked it and I was going to put the motor going the other direction, but I would have had to have a longer belt than what I have in order to get the clearance I want from here to where the motor would be, which I want that to be at least the same as it would be down to the ways. So I decided this is where I'm going to put it right here, and I got it blocked up. My points to mount are right here, those two holes right here, and I have some 4x4 angle out there. I'm going to make a bracket, and I may have to, I didn't really want to drill any more holes, but I may drill another hole here, or use this one. Yeah, I can use that one. And I'm going to come down here with it, and then I'm going to use a total different approach for actually making the motor mount. I'm going to make it out of cutting board. I saw a guy do this and it worked. It looked to me like it worked real well. Here it is right here. You can buy this cutting board sands. I bought a couple of them because I use them to make molds, as you can see, for pin castings. I'm going to make my mount out of this. It's going to have a hole in it right here for the motor to go in, and then it'll clamp on it to tighten it, and it'll bolt down. Hard for me to explain. I'll just have to show it to you as I get there. But here's where we are. I think it's thinking time now. I'm not going to just get off and start cutting metal and laying it. I got to lay back and think. I'm thinking very seriously about taking this fan apparatus off. It sort of looks rinky-dink, but then I am concerned about cooling. Oh, I'm not real sure what to do about that, but I can always take it off later, I guess. Okay, I'll get back when I make a little more progress. Okay, when I started this project, I told you I was going to do it in excruciating detail, so it's exactly what I'm going to do. I'm just not the guy that says, well, I made a bracket. I'm going to show you how I did it. That's not quite true. I'm not going to show you all the sawing and stuff. I'm going to show you each part individually. Now this is exactly where the motor is going to sit. It's be tight right to here. Just a little minor alignment. It's going to sit exactly right here. All right, now take this off. All right, see what I did there? I built took a piece of angle iron, drilled 2 holes here and here, and built me a platform here. Now this is where I'm going to build the cradles. Okay, I've got the bottom half of the cradle built. I'm going to show you how that looks. It'll sit here just like that. You can see I can tighten the belt. I'm going to put some bolts through the bottom and elongate the holes so that it will adjust back and forth. But basically, there it is. You can see it's just a get this off of here. And it gets heavy with one hand. There you go. That's all it is right there. And then I'll do one. I'll do one almost like it for the top half. It'll just be these end pieces, and they'll screw down on top and sandwich them in between. And there you have it, my friends. That will be the mount. It ought to be solid as a rock. And before you know it, we're going to have a running lathe. All right, the motor is mounted. I have to build some covers for it, but you can see how I did it. And down here in the bottom, those, you can't see it, but there's some washers over it, but those holes are elongated to allow the motor to slide backwards and forwards to adjust the belt or take it off and replace it. So I'm going to build some flat covers for it. I may mount a fan in it because I am concerned about how much heat this thing's going to put out. And we'll see when I get that done. All right, I'm going to do a test run here. I've got the pickup for the tack hooked in. I am going to have to buy a new upper pulley. It has a little wobble in it I don't like, and it shows up as a vibration. I've got this all hooked up right here. Here's the tachometer. I'll spin it up. I need to turn it on first. Spin it up. There we go. There's 800 right there. Very nice. 800. There we go. We got a little over 3,000. Looking good. I had to go back to the drawing board. I didn't really have to because this one worked fine. This was on the headstock main shaft, and it has a 1-inch bore. I had assumed that this was 1 inch. This was 1 inch, but it's not. It's metric. It's not quite 1 inch. So I even had another pulley ordered. Well, I've got the other pulley, and I was going to just bore it out to fit that. But when I was just looking around the other day, I remembered this Rees pulley here, which I had, busted the ear off it and had to use JB weld, which is probably stronger now than it was before because, this is just pot metal. But then I thought, well, I looked at it and I said, well, it's got another bearing in it here, and that's really going to give a lot of extra support, and it just slides up on. So what I did, I'm getting ready to do, I took the other half of this and I made a spacer. I made it out of wood, and it goes into here like this, and of course then this will slide together like that. Okay, now that's going to give me my 1/2 inch for my belt to go into, just perfectly like that. So I'm going to put it back on the shaft. It has 2 set screws to hold it in place, plus I'm probably going to put some kind of spacer or something out to, I don't know, can you see, yeah, right here there's a C-clip slot. I'm going to put some kind of spacer right there. So this is keyed and all that kind of mess, so I'll get this back on and my belt on. And I will talk to you later, I think. Alright, before I put it back on, well, paint it and put it back on, I want to show you what the mount looks like. It's probably overkill, but I just built with, supplies on hand. It's a piece of angle iron, 4x4, and I cut it out with a bandsaw, metal bandsaw. I welded a gusset right here because when I had it on before, I noticed it was trying to give it just a little wobble. I don't know why, but like I said, that's probably overkill. The guy could build all this out of wood. It wouldn't really be that big of a problem. You just have to make sure you really glued it up and had some gussets and stuff like that. Okay, I'm going to get this painted and put on, and then I'm going to put the motor on, show you what that looks like. All right, I've got the, I guess for a better term, motor mount sitting right here. I just wanted to show it to you before I started covering it up. I told you I was going to try to do a very detailed explanation of this, and that's what I'm doing. All right, where the pulley went on right here, I couldn't find the spacer to put in here, and I put the C-clap on and I wrapped that with stainless steel tape. So even if the set screws right here happen to give up, I don't believe it can slide out, and that would open this up. Okay, here's the pickup for the tachometer. This is pot metal, sorry pot metal I might add. So my magnet I had the JB welded on. It passes right there as you can see. All right, the motor's going to sit right here. And I'm going to sit it on here. Put it on it right here. And the motor's going to sit something like this. Something like that right there. May have to do a little modifying because this pulley's just a little bit bigger around than the other one I had on it, which is actually a good thing because it lets you spin this slower. And at the same time, with the speed of this, 7,000 RPM, you can get all the speed you possibly could ever need. Now, all right, we're back to handheld. Just too much moving around to show everything. I just want to show you a couple things I'm in the midst of doing. Motor sit approximately right here. I've got to cut out right here a little bit so I can slide it in, but I'm going to mount a fan right here on top. It's going to either blow down or suck out, I'm not sure. I've already got the fan here to suck it through, and of course I'm going to cover everything. All right, up in the front I built a wooden covering, goes over this, it covers everything. So my instrumentation is going to have a tachometer here and a temperature gauge here, and on the back side right here I'm going to put a 110 outlet or a 115 outlet right here for using glue guns, etc. Now my major control is going to mount, if I can hold it, it's actually fairly heavy. It's going to mount right here. So you can see how that's going to work. So that's where that's going to be. It leaves plenty of room for the deal. And I've designed everything where the head will still twist around. All right, there it is. The only thing I need to do now is finish building the cosmetic part. I'm going to use Kidex for that to build a cover on it, I guess. Cover the motor. Else in the back here I have two fans. This one's still on. This one's sucking out. This where I'm going to enclose this right here and put some vents in here so to pull air over the motor. I've ran this for about 20 minutes at 2,500 RPM, and it only got up to 124 degrees. And I really don't know what the baseline is, so I can't tell you that. Notice I put a 115 volt outlet on the back here, like for glue guns and stuff like that. This is just a place for me to put my caps on my super glue and stuff. I always seem to lay them down somewhere and can't find them, and when they get into the shavings, you can forget them. This temperature gauge right here, hold it still so you can read it. Right now it's at 89.6 degrees, and the tachometer works very simple. This is a safety switch here. You have to pull it out and move it to there. That way you cannot do it. It's off right there, and right there would be reverse. Okay, this is your on and off switch. Your light comes on, and this is your rheostat. There you go. There's your 1,000 RPM. It's relatively quiet. It's certainly quieter than it was. Turn it all the way back down and turn it off. Over on this side, I'm turning all my instrumentation and my fans off right here on this switch, and they all shut off. So, like I said, all I need to do now is to build a case on it with Kidex. I have quite a bit of Kidex. I was in building holsters and knife sheaths for a while when I was making my knives. So, let's get on with it, and when I get her all purdied up, I'll take some more pictures, and then I believe we'll be done, my friends. All right, it's done. Next step is to move it back into my wood turning room and take a quick walk around. I think it turned out pretty nice. I think it looks pretty professional. In case you're wondering, I built all the coverings out of Kidex. I'm going to show you how that's done in a minute. A little demonstration of using Kidex, not necessarily how I made this. There's you have an exhaust fan here, and on the end you have one. It keeps it nice and cool. On the front we have a tachometer and we have a temperature gauge. The motor is now at 66.2 degrees. Turn it on. Orange light comes on. Going to give it some oomph here. There you go. At about 700 RPM. Relatively quiet, certainly quieter than it was before. The wood I have on there is ironwood. Maybe it was a little too hard to cast. I can turn it on up. There's about 1700 right there. Barely humming. Turn it off. This little switch, you have to pull it mid-center and down. Turn it back on. Goes the other way. Off. Pull. Center. Center. You cannot move this switch unless you pull this little knob. So there's where you keep it. Rheostat. Turn it back on. There's your a good roughing speed right there. There's your good turning speed. I don't want to spin it too much faster, but it's 2,000 pretty easy. It's not balanced very well, so I'm turning it back down. Needless to say, I think I'm pretty happy with it. And I'll be putting it in the other room here in a little while, and I'll show you from the other room. Walk around one more time. There you go. Got the power supply to the instruments and to the fans on the back of it, and an extra outlet for my hot glue gun or whatever. Well, I owe everybody an apology. I built all the covers, and I guess I just got excited building them and I forgot to film it. So I built them out of Kidex. Kidex is mostly used for building knife sheaths and holsters and stuff like that. It's Kydex, is how you spell it. There must be 500 videos on YouTube about it. That's how I learned to use it. It's a very simplistic thing to use. It doesn't require a lot of equipment or supplies. You can buy it. You can buy it in sheets. You know, here's in colors and different thicknesses. Here's some black, and here's a piece of red and stuff like that. I thought I would do just a real quick demonstration. I know it's sort of off the subject, but it is what I built my covers out of, and you'll be seeing those very shortly. First, when I built my covers, you know, I patterned them using cardboard. I actually use cereal boxes is what I use to make my patterns out of, and then I trace them on the Kidex, and I cut them out on my little bandsaw. You can actually scribe them with a box cutter, and then they will break. So what you do is I use a little bend and break. You can use the edge of the table or whatever. So what you do is you take and put it like this. Take and put you a piece of metal on your bend and break, and use a couple C-clamps. I'll do this real fast just to get an idea of how this works. When you heat the Kidex up, you can heat it in several ways. If you're making knife sheaths and stuff like that, you generally use a toaster oven or even your own oven, but you can use for small things, you can use a heat gun. That's what I'm going to use right here. So basically you put it in here like this, and you stick the heat gun to it, and you just get it hot. And you don't want to get it to the point that you melt it, but you do want to get it where it's pliable. And that way you can form your edges and your creases and your bends. And it stays like this, and then put a little pressure on it. And as it gets hot, you add a little bit more pressure. You don't have to be real careful about melting it. But it will melt, so just keep the deal on here. You can see if you guys want to buy me something for Christmas, I need a new heat gun. And you just keep that in here, go right into the crease, and it'll give up here shortly. There you go, I'm starting to smell it a little bit. Alright, put it right there. Alright. Just leave it there for a second. Like I was saying, this is an easy skill to learn. I don't like to, put down anybody else's hobbies, but if you wanted to start a new skill and didn't want to invest a lot of money, and this is a very handy thing to do, I would suggest it. It's a lot of fun. You can make all kinds of holders and I've got my flashlight on my side, and I made a Kidex holster for it, and I've got some where I hang some of my tools and stuff like that. All right, that's it right there. Basically, then you undo it right here. And this is how you make all your edges and stuff. Pretty simple. There you go. When it gets hard, it is, you're not going to bend it. And one of the things I like about it here, I mean, that's some tough stuff there. One thing I like about it, you see it right here. You make a mistake. Watch this. This is so neat. There's something right here. Push her back down. There you go. You've got it back just like it was now. And you can start over. Might have a little crease, but most of the time it'll come out totally. Well, that's it, my friends. That's how I made the covers. Made them out of this Kidex right here. So, and it makes beautiful little covers, and they look factory. So thank you, and let's get back to what we came here for. One thing I enjoyed about that, if you didn't notice, I was taking some big, bad, deep cuts with this, and it was not dragging it down. In fact, I spun it in the Morse taper a couple of times there. It has so much power, it might be overpowered. Anyway, it's done, and I want to thank you for your time. Take care of yourself, and if you see fit, I would really appreciate it if you would subscribe to my channel. I wouldn't mind building up a few subscribers. Like I said before, if you've got any questions, just go ahead and send them to me, and I will answer them as prompt as I can and as concise as I can. Got one little announcement I want to make before I get out of here. Peter Matthews, I appreciate the shout out you gave me a week or so ago. It said I got a few more subscribers, and I'm returning the favor. I enjoy your channel. I want to thank you for putting me onto this Grizzly bandsaw. It's one heck of a saw. I went ahead and bought me a 3 TPI blade for it. It works real well. I'd have one complaint though, and if you got a connection, let's see what you can do about it. They got wrinkles in my bear. That's not good. Low quality. Anyway, folks, I'm going to go make something now, and thank you very much.